Mhm. Yeah. Um, is it try to have a decency? Yeah, there we go. Okay, so systems of logic. You're live. Why is this set to an hour? That's not good. Okay, let me diagnose that. YouTube stream. Why is it set to 1 hour? I'll just leave it. You know what? No, it doesn't matter. Okay, so hello everybody. It's been a long time since our last stream. I know I'm talking to no one right now, but to keep up my sanity and just to make sure that I keep talking, yeah, I'm just gonna be constantly saying things throughout. I hope that these are somewhat reasonable things. We've got to keep the dead air to. Is it dead air? What was the thing it's called in radio? It is dead air, isn't it? Okay, dead air. Yeah, so dead air. We gotta keep it to a minimum. So yeah. So this stream is a bit of a strange one, you could say. What it is essentially, we are going to be covering the new Turing Omnibus. So this is the book that we are doing. It's a bit odd because you look at the title and you think, wow, this is like this must be a kindergartner's book, right? Like, there's a fucking bus on there. This is just a ripoff of the Magic School Bus. This is like a Chinese ripoff of the Magic School Bus from the 90s, right? Like, surely the new Turing Omnibus does not speak computer science, and yet, for some odd reason, you go onto Oxford. Okay, Oxford. What is it? Oxford Computer Science reading list. Let's go on there. And you scroll a bit, and somewhere within here will be the new Turing Omnibus. Mini articles on computer science topics, and there were a bunch of others too, which I really don't plan on going through. Like, I'm pretty sure I read Code, the Hidden Language of Computer Hardware and Software, which is by and far a decent book if you're starting out. But overall, I think it's a bit. It doesn't really cover things in much depth, and a lot of the things in it are already covered by the GCSE and A level syllabus. So perhaps if you're in the very odd situation where you're not doing A level computer science and you want to apply for Oxford, then sure, maybe you might want to do this. But otherwise, it's a bit irrelevant. Like, just, you're just rehashing stuff from high school. It's not exactly useful, is it? And then there are a bunch of these which are, let me see if I can recall anything. I'm pretty sure school has a copy of this algorithmic puzzles. But again, algorithmic puzzles is, you know, well, it's not boring. I can't say that, or else the Oxbridge people will be listening into this stream, and then they will immediately mark me off the list for being not being intellectually curious enough or something. But well, like puzzles. Puzzles has very different connotations. Like there's puzzles, and then there's things which are actually useful, right? Like the new Turing Omnibus, that doesn't mean anything. The new Turing Omnibus, it's like buses. Buses are like like data bus, address bus. It could be useful. It sounds like it's something that could be applicable in real life. And you know what? You look at the table of contents, it is actually quite useful. Like you look at it. Give me a second. Okay, yeah, you look at some of these and you're like, wow, I recognize these. Like game trees, the min-max method. Wow, it's the min-max method. You use this for like chess engines, and like if you want to explore some more, you can combine it with like alpha beta pruning, and that's really useful, right? Chomsky hierarchy, maybe a bit less useful. Some of these are pretty theoretical and not that directly useful, but still minimum spanning trees. Like, damn, I saw my friend implement that in his A level coursework. It's been used before by like a real living person. Whereas you look at fucking algorithmic puzzles, and it's like the majority of them are just shortest distance. You gotta construct a proof that this puzzle has no solution. Like, yeah, I get proofs are important for mathematics, but you know, why not just learn actual proofs? Like like actual mathematical proofs with like numbers. You know, that sounds a bit useful, isn't it? It's just yeah, I don't really get the point of these like puzzles things. And to some extent, I guess Project Euler and stuff is in the same vein, but at least you get to practice your programming skills, right? At least you get to get familiar with like C++ or whatever. But this is just like even if it isn't a waste of time, it feels like a waste of time, and I don't think I'd ever be able to enjoy doing it. So we're never doing those. Yeah. Yeah, anyways, that's enough, I guess. I don't know what any of these are. And also, just odd coincidence, if you look at the Cambridge Computer Science oh, reading list, then you will find preparing to study computer science. Is this it? No, this is the one where you already admitted. This complete reading list? Nope. This doesn't look like it. To get in? Yes, how to get in? Okay, so how to get in? They go on and brag like, oh, highly sought after, finance. There you go, the quants, programmers, predictably, yeah, whatever. Okay, the point is, where is the course outline, entry requirements, blah blah, CSAT, choosing. Okay, there is a reading list. I swear. Recommended resources. Wait, recommended reading maybe? Yeah, yeah, that looks like it. Yes, okay. So, general reading, it's the new Turing Omnibus and computational thinking. Computational thinking is literally like 3 pages worth. I couldn't be bothered to read this, to be honest. Like, it's gonna come back to bite me in the ass. I'm just saying, they're gonna run a bot, okay? They're gonna the Cambridge, the people at Cambridge being very smart, they're gonna build a bot. It's gonna run through all of my streams. It's gonna record every single word I've ever said, and somewhere in there, they're gonna find a lie in my personal statement that's going to immediately catch me out. So yeah, I'm gonna say yeah. I haven't read this before. If I lie on my personal statement, I mean no, there's a two month period. I could have read it, you know. It's just assume I'm telling the truth, but yeah, for now I haven't read it. If I say specifically I read it in like July or something, yeah, I'm probably lying. But still. Anyways, let's get back to the point. So, the new Turing Omnibus, it appears on both Cambridge and Oxford, which is very nice. So, the reason that this is useful to me, or to you, right? To you, because you're listening to the stream, I hope, is that if we read it, we will get in to Oxbridge. So we're gonna cover this pretty methodically. My original hope was to do a daily stream. Bit ambitious, you know, daily stream. My idea was, oh hey, well these are each pretty short, right? This is 8 pages. I think, or seven. I don't know. It's 7 pages maybe, and then this is 5 pages. Five? Yeah, five. I think five. Yeah. So, anyways, pretty short. You could probably get through them pretty quickly. So my thinking was I'll do 3 chapters a day, which is why in the thumbnail and the title it will be reflected, right? It's like, oh, we are doing finite automata, systems of logic, and simulation. But the thing is, I actually realized um about this thing called laziness. You know, you might have guessed it from like my profile picture, which is of the laziest possible emoticon texticon that I could find, and also my channel name, which is called Laze and Lie, and half of that is lying, as previously discussed, and half of that is lazing. So, with that in mind, I've decided that in order to keep my channel on brand, in order to not violate any of my sacred lore, um, I was gonna just not do the first stream. Well, okay. Originally, I set it at like 2 p.m. Right, 2 p.m. yesterday or something, and then I ignored that, and then at 4 p.m. I set it to 8 p.m. and then I ignored that also, and now it's today. It is about to be 11 p.m. So I've only missed my deadline, but I've only missed my deadline by around 33 hours, which isn't that many. Like 33 hours, you know. Like if I show up to the TMUA 33 hours late, it's not that unacceptable, is it? It could be worse. Anyways, so let's get to work, right? Because I've been talking to myself long enough. People might start to think I have mental issues. Uh, I love talking to myself. So, um, we are doing not algorithms today. Now, you will notice. Oh, hey, why not algorithms? Well, you see. Because actually, we're computer scientists, and we start at zero. We do zero-based indexing. So actually, we're starting at the icons, which we're gonna go take a look at. The preface is blah blah Turing blah. This faithful sabbatical at Oxford. Parks, whatever chapters, derivatives, acknowledgements, icons. Okay, so in the future, I've been putting a modicum of thought to this. In the future, I might actually focus one or two chapters down, like spray them down all at once. For example, I could see myself doing like a long stream, just doing computer graphics. And now, would that be a pain in the ass because computer graphics requires lots of math and also lots of programming? Yeah, probably. But at the same time, it does seem easier to make thumbnails for, and I spent like an hour doing thumbnails, so like with the one thumbnail for this video, I took a fucking hour on it. I don't know why. I had the idea like from the start. It just took me forever to like fix all the tiny details and like I stole a copyrighted image off the internet. I don't know if you noticed that. I don't do any of my own graphics because who does that? I mean, graphics. Graphics not my concern. I'm a programmer. Fuck that. But the point is, I had to steal that graphic, and I had to remove the background, which took me 15 minutes somehow. Which I probably would have done better if I had some knowledge of computer graphics. Yeah, I wonder how it is actually done. I mean, the website that you use, you can just look it up, is like background remover, right? Yeah, like background remover, free, and it's just this. So it removes like shades of white, but I suspect I wouldn't actually remove like a stickman, for example, right? Like, what happens if you just put it like a white, like a stickman? Because like, would it also remove the bits that were bounded inside? Yeah, actually, that's a good question. Let's test that. Okay, so cookie. I will accept your cookie. Thank you. So it does. Okay, so yeah, it just strips white from the entire image, and probably does that with like kind of bounds. Like it puts like an interval of white. Like you could probably represent it in like not RGB, one of the other ones. Like what's it called again? Like CK, like the one that you use for computer graphics, like CYMK. Like no, that's not it, is it? That one no, that's for printers, but you get what I mean, right? Representing the color in something other than RGB that makes it easier for you to set the intervals, and then basically just wiping the entire image, like every individual pixel doing them. I hope that was a better explanation. I hope that was a decent explanation, and if it wasn't, which I fully anticipate, that I will be able to deliver a better explanation when we do all of these. So, yeah. One problem with the thumbnail thing is that we might have to do these like split in like half, because I don't think I'm doing 9 chapters all at once unless I put a marathon. But I don't have that kind of endurance, man. I'm getting started with the streaming thing. I have a lot of energy, right? I have a lot of energy. I think I can at least pretend to have energy while I'm on stream. But at the same time, does it sound fun? Like, not really. But at the same time, would it contribute to me getting into Oxbridge? Yes, probably. I hope. So, yeah, I don't know. We'll figure it out after we do the stream, I guess. Well, okay, so after a lot of talking, right? I glossed over algorithms. I made up a reason that wasn't a reason. So basically, the reason that we aren't doing algorithms, cooking up, by the way, cooking up. The book is from like 1993. Cooking up programs. The reason we're not doing algorithms is that it's boring as hell. It's like, oh wow, this is an algorithm. You can use it. And then the exercise is even more boring. It's like write your favorite recipe as an algorithm. How much more complicated does it become if to be used by a novel cook? Rewrite the wallpaper, blah blah. It's just boring, right? It's boring. This is a creative writing exercise, and this probably isn't actually, but it's boring. I don't want to do it, and I'm not going to do it then. Yeah. So next up, we're going to skip. So finally, after how many minutes of talking? After let's see. How do I check how long the stream's been running? After 15 minutes of talking, we are gonna get started with finite automata. So how do I do this? Let's just flip the screen over so I can actually write on it. So, finite automata, the black box, which, by the way, finite automata, great name. It occasionally happens in industry, military, or educational settings that one is presented with a piece of electronic hardware that you don't know about, right? One piece of discovering how the device works, take it apart, and to figure it out. This is not always possible, so we can, therefore, given that it has both input and output, we can discover what it does without ever taking it apart because it's a black box. So yeah, it's a box, it's black. Let's just draw a black box very nicely because this is one note in black mode, in dark mode. It's a black box. Yeah, so this is what we're trying to figure out. It's terrible drawing, but regardless. So yeah, let's imagine a box, which they have also drawn for us, delightfully, bearing electronic input, accept, and reset. Yes. So basically, a lamp reset, accept, and a push button named reset. It accepts zeros and ones. You put a bunch of numbers in, and then it is accepted. Yay! For a time, we are stymied and even begin to imagine that the circuitry inside the box is behaving randomly. Then someone tries the same sequence, and there it goes on again. Continuing these experiments, we discover that other things also light the lamp. Great! To do such an analysis, we must assume that the contents of the box are in some kind of stable equilibrium between one input signal and the next. So nothing changes in between you putting in one number and the other. There are no side effects. I guess not. There's like the inverse of side effects. Because the side effect is something that comes out of the output, right? But this is not a side effect. Okay, yeah. Let me do some drawings. Why not? So let's see. Let's see. Just give it a little light. Okay, this might need to be bigger in second thought. So it's a terrible drawing. Okay. Okay. This just no. How do you like draw? How do you like draw a circle? A circle? Circle? I didn't look right. I didn't do GCSE art. Okay, I did not do art. I did not do creatives. I'm not a creative person. Good enough, right? Except I'm running out of battery on my computer. That might not be a great thing. That is not good. Okay. Okay, so continuing on, after drawing a poem there, we note these. We also assume that the interior circuitry only exists in a finite number of states because the device is manufactured as opposed to created what by God? Are we assuming that this box came about by evolution? What is this? Oh Lord. Okay. So it is a finite automata. Let's see. Finite collection of states. Yeah. Of states. We're not gonna put in the symbols because I really don't really care what they mean. I don't think they're relevant later, are they? I don't really think they are, so it should be fine. The finite alphabet of inputs. Lovely. And of course, a function. We love functions. Oh god, no, I don't like symbols. Function that determines new state based on the state output. No, input. There were two of them. I got them wrong. Right. So this is a finite automata. It has a finite amount of states, a finite amount of things it can states it can be in, finite amount of things it can take in, and then it determines new state based on its stated input. Yeah. So we also assume that does not change states in between inputs. Oh fuck. In between the inputs, which is lovely. Oh, inputs. And of course, most deliberately, it. Hmm? What's the last thing again? Oh yeah, and the finite amount of states, which is irrelevant, right? So yeah, this is a finite automata. We've done it. So there are a number of special states, right? Special states. Special states. A special state is what I am in all the time because I am special. Special state. Which you know words. I hope you speak English. You can comprehend this, and an accepting state. Yeah. So, accepting state causes accept to light up. Yes, lovely. Yeah. I'm just gonna call it an FA, right? So yeah, actually I should make it clear that the Football Association. Oh, the football. The drama of FIFA. Anyways. So a finite automation is said to accepts any sequence that puts it oop, in final state. Oof, lovely. So yeah. Okay, so these are the special states, and there's more terminology. A language, which is set of sequences that put the accepted by DFA, DFA, because the Football Association is a proper noun. With this terminology, then, is it possible to determine the language of the automaton inside the black box? I mean, it does sound possible. Can we succinctly describe the set of all binary sequences that cause the low light to lamp? What? These, after all, are the words of the language. Because the automaton has a finite amount of states, we might suppose this to be a reasonable project. But after a number of experiences, experiments, we find ourselves beset with doubt. After all, for example, following words are accepted. So, the 0101, 01000101, and so on and so forth. Yeah, so this, it's really easy to just look at this and then determine it accepts this thing, right? The form 01 and any amount of 001 and then 01. And yeah, it's a symbol. So, we now are introduced to a big word, state transition diagram, which I'm hoping that is kind of familiar to people. Like, this is basically like an advanced version of a flowchart, right? So, yeah. Mm, yeah, okay. So let's try and explain this, right? So this is the first state, and states are numbered, but not by 0, 1, just by like decimals, right? So this is the zero state, because we are actually computer scientists and we are going to be starting from zero. And then this is just the 0 or the 1 we take in. If it's zero, it just goes nowhere. If it's one, it goes somewhere. If it goes nowhere, it's just not valid. So yeah, yeah, I'm not gonna draw this whole thing out, but you get the point. Yeah. Yeah, so this is a zeros one. Yeah, so something like that, right? This is kind of a bit confusing at the very start. It's just because you have to realize, yeah, the states are numbered for some reason. It might have been nice if they used like A, B, C, D, and so on, but whatever, there's 60. I guess it might be because there are like only 26 letters, but at the same time, you could just do what Excel does and go like, oh, Z, oh no, what we're gonna do? Well, A, A, B, and so on. Oh, whatever. Um, okay, redundancies aside, we need to go faster. We've spent almost half an hour here already. Oh, Lord. Okay, so. What are we doing, boys? What are we doing? Give me a second. I just messed it up. Where's my screen? Okay, so at this point. Oh wait, no. Okay, so interestingly enough, so now let's look a little closely back at this because now this becomes relevant. So we know that the black box accepts these numbers, and we can formulate a state transition diagram that accepts that language. However, we could we could be wrong. How do we know that this diagram is correct? We do not, because we can imagine other diagrams which give the same results for these four specific inputs specifically. Just like how pretty much for any like series of numbers, the non-infinite series of numbers, I guess you could try and formulate some weird ass function that does it. Like if you do like 1 2 3 4, I'm 1 2 3 4, I'm sure you could figure out that this is increments of one. But also you could probably make some fuck ass polynomial that goes like, oh, 1 2 3 4 305 380,000. So yeah, you get my point. You could put in practically, no, you couldn't put in practically anything, but you could formulate many machines that accept the same four inputs here. So they give us some examples, lovely enough. So this is one possible example. So essentially what it does here is that, well, it brute forces it. So it just manually, you might be familiar with this if you've done any kind of programming at all. Like, like what this does is that it literally just goes zero, wait, what is it? Yeah, 0 1 0 1, and then uh let's see. And it accepts it. Wait, what? Let me see. Yeah, okay, wait. So 0 1 0, and then state free, which is important. If it's one, then it just accepts it. If it's zero, then it goes here, and then continues to 0 1, and then from there it has choice, either continue on one loop deeper into the iteration or just end, right? But the problem with this is that since it's a finite automata, you can't actually have infinite loops here. Like eventually you would, like, eventually, if you consider 5 6 7 as one thing, or like one chunk, and then you consider 8 5 8 8 9 10 as another chunk, eventually you're gonna run out of chunks. You don't have infinite chunks. No, it's not Minecraft, so yeah, you do run out, unless you're a filthy Java player, in which case your opinion is irrelevant. So next up, our thoughtful member of our investigative team might happen to turn over the black box and discover the following label. So we know that there are 6 states. It is, at last, possible to determine precisely the language accepted. A certain theory tells us if that the automaton accepts that, then it will accept all words in the set that, for some reason, because you don't get to know yet. But there it is a thing, which we will find out in chapter 14. Plus, we may figure out. Um, Actually, I've missed quite a bit of this, haven't I? Let's see. How can I repair my idiotic notes? Let's see. Okay, I can just make one note, right? Okay, so let's see. How to figure out um language accepted by ANFA? Is it ANFA or a finite automata? No, it's AFA. By AFA. Yeah. So, let's see. Given, for example, let's just go with the same one, right? 0, 1, 0, 0, 1, 0, 1, 0, so forth. Uh, Given these numbers, there is multiple possible machines that accept these inputs, but may also, gosh, rock, accept other inputs. So yeah, but if we bound, no, not bound, if we know, if we know how many states there are, we can prove things about language. Yeah. So now it's just this terminology. Yeah. This means any number of repetitions. I am sorry if this is a bit redundant, but I guess we can just go ahead and remind you all. Any number of repetitions of 0, 0, 1, and then this set. Uh, what does this symbol mean? Let's see. Okay, let's Google it. One. Let's see. Rotated U with line under. How do you spell under? Under? Under the sea, programming Z. That's not it. 99 degrees. Ah, so subset of or equal to. Yeah. So this symbol means. Sorry, I haven't been doing much set theory, so I apologize if that was, to be quite frank, fucking obvious. But, yeah, or equal to. So, yeah, so we can translate this into plain language, which is that this set is the subset of or equal to a language. Lovely. So a systematic exploration of the possibilities leads us, let's say, to this, right? So yeah. Okay, so let's go over this now. A systematic exploration of us leads us to another such conclusion. We could then write, since these two are both accepted into the language, that a plus sign, right? We could say it's either this or this, or I guess it's not or. I guess it's like merging the two sets together. They are both accepted by the language. Yeah. So, is this important enough to note? Yes. You know what? So yeah, 0, 1, 0, 1 plus 0, 1 package B. Uh, Both. Yeah, both sets are accepted by Z. Anyway, so regular expressions. Now let's talk about regular expressions. What are expressions? You've probably heard of them before. If you don't recognize the word regular expression, maybe this regex. Lovely. Regex is that one really fucking complicated. Well, if you're a wizard, then no, but for normal people, quite fucking complicated. Uh, it's difficult to explain. It's like a language that only accepts certain words, which sounds suspiciously similar to what we are currently studying, finite automata, which is because they are basically the same thing. The language accepted by finite automaton can always be written as a regular expression, obtained by applying the following rules: 0 and 1. Okay, so let's start. F a wait, a language. Okay, so language accepted. Oop, automaton is right as a regex. So let's see. 0 and 1. A regex. If x, y are regex, shit. I'm not a very good writer, am I? I'm out of practice. So is concatenation xy and sum x plus y. If x is regex, so is iteration x x x asterisk. I don't know. Yeah, the iteration is always a regular expression, and this really shouldn't take a lot of brain power to figure out. You can just look at it. I hope. Can you? Because we're gonna ask you to prove it, aren't you? Yeah, something similar. Yeah. So basically, they're telling you that this is a thing. Moreover, for every regular expression, I guess okay. So moreover, for every regular expression, there is an automaton that accepts the regular that accepts the okay. For every regular expression, there is an automaton that accepts the language symbolized by the expression. Vice versa. For every regex is there is an automaton. Lovely. It's kind of weird, right? Automaton is such a lovely. It's okay. Automaton is an A tier word. Okay, automaton. It's cool. It's got that edge to it. You know, like if you're in a video game and you're fighting an automaton, it's probably like either it's a really pathetic enemy, like a genuinely like a trash tier enemy they throw at you at the start of the game, or it's kind of badass, automaton. It's like wow. I can think of that being like the moment where the game kind of subtly reveals like a sci-fi backdrop or something, like Shangri-La Frontier or something. But automata, S tier. S tier. We should use that more often. Automata. It's like, wow. Can you imagine like being in like a JRPG and fighting like a swarm of like automata? It's awesome. Like Conway's Game of Life, but like as an actual video game boss. Awesome. Awesome. So much aura. It's probably been done already. I'm not a very creative person, not a very original person, anyways. Creative, yes, but not original. But that's cool. It's cool. Anyways, we continue. So a regular expression is that a finite automata is the simplest kind. So we might want to add that as like an addendum somewhere. Uh, Okay, so limitations, simplest kind, cannot accept. Simplest kind of computational model, which we'll be looking at cooler computational models like Chomsky hierarchies, the one I just mentioned. It's a bit of foreshadowing in it. Cannot accept some, e.g., palindromes, but I think um, it was pretty readily obvious by the name finite that it did have some limitations, can't compare infinity. So yeah, those are our notes. So if there are any questions, I don't think there are gonna be, but if there are questions, please put them in the chat, and then I guess we'll look at that. But it won't be needed because we have no viewers, and I'm gonna be very sad. So yeah, finite automata. These are our notes. I guess that's cool. I don't really know. Do I upload these or something? I don't know. Well, the point of this, right? The most important point of this was to tackle the problems, which is not going to be possible if my OneNote is cooked. Okay, let me think. How do I solve this on stream? Let's see. It's like slightly normal now. I mean, it's kind of normal. No, not really. No, it's getting worse. Come on, you can do it. Oh, hey, it's actually normal now. Oh, I'll be damned. Okay, right. So, I guess we'll scroll a bit down and do some exercises. It's kind of, get in the tune. So, 1A, describe a finite automata that accept languages. Ooh, so they're giving us languages and we're going to have to draw state transition diagrams to figure them out. It's going to be a little difficult on OneNote, but we will do our best. So, AB, let's see. So we start here, 0, right? And probably, what's this, right? A, whoop, we, whoop, we, B. Ta-da! Right. And so if we reach this point, we're like B. Hmm. Oh, this is difficult. Okay. So the first part seems easier. What's the problem is how do you decide whether or not to transition to the second part? Interesting. Okay, this is quite a conundrum. And just to make sure, a plus symbol means the concatenation. So, in the second one, you can accept either A or B, which is funny, very funny. So basically, that means B. Okay, so obviously, if you put in a double A, then it's not going to be valid anymore. So it's just going to go to nowhere. But if you put in B, then you will lead to a third state, which is going to be confusing to deal with, to say the least. So I guess we'll do the simple thing, right? Since both A and B are valid, we'll just split this off into state number 4 and state number 5, and then we'll start thinking about these ones individually. So in the case where it's A, B, A, then it could either go back, right? So it could go back if it's B. So actually, it could go back if it's B. But if it's A, it goes to a state in which it can only accept A or B. Hmm. That's odd. But then it has no accepting state. Hmm. Okay, I think I might have ran into a problem here. Like AB is fairly obvious, right? So let's just write this out. AB is fairly obvious, right? Like AB, that's valid. AB, valid, 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 right? Quite simple. But if we're looking at A plus B, does it mean that the OR expression is evaluated individually? or is it evaluated as a whole? What do I mean? What do I mean? So okay, let's take like AAA, which we know is going to be accepted because no matter if you look at it individually or as a whole, it's going to be accepted. But if you look at ABA, it could be like the specific way they've explained it makes it kind of ambiguous. Um, yeah, the specific way if like postulated it makes it kind of ambiguous. Yeah. I guess this is like sorry, this is gonna be a bit nerdy, and I wanted to do this on a later stream, but I guess this is a problem of evaluative order evaluation versus normal order evaluation, right? Yeah, it kind of is. It's kind of like a rehash of the same problem. So if it was like the or statement was decided before the repetition, then this wouldn't be legal, but this would be. Yeah, that's odd. Um, hmm. Okay, so a finite automata has to have a finishing state. So let's just assume for now that it is that the whole thing is processed as a whole. So basically, it can only be a any amount of a or b any amount of b. So yeah, that seems easier. So yeah, if it's a, the a goes there. If it's let's see, if it's so five, if it's a, then it goes here. Then it just kind of loops to itself. If it's a. Wait, how do you write the finishing state again? Give me a second. I might be dumb. Oh wait, you can. So the accepting state doesn't end it. Okay, no, I've made a confuzzlement. Okay, so an accepting state doesn't actually end the entire expression immediately once you arrive at it. You can still do stuff with it, like you can still like go from place to place, whatever. Yeah, okay, that was done with me. So you shouldn't make that assumption actually. I guess it might be kind of fun to do both. Okay, let's try and do the one that we were talking about first. So yeah. Oh, oh no. But then it might have two acceptance states. I don't think that's allowed, is it? There's only one accepting state. Because okay, let's think about this, right? If you had to draw individual acceptance states, so this would be A, and then if it was A again, it just loop out on itself, and if it was B, then it just go nowhere. And then pretty much the same thing for this. And then this would be an acceptance state, and this would be an acceptance state. So actually, it is bound to be, according to how we've defined a finite automata, that both of these lead to one of them, right? Oh, wait, no, 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 no. This never loops back. This never loops back. Okay, so just looking at the first one, right? Let's not get ahead of ourselves. Let's just look at a third state and get it done. A, it goes A, B, A. Then it could be A or B. So if it is a, let me guess, A, oh, A and B, it doesn't really matter anyways. Wait, this is kind of redundant, isn't it? Okay, okay, ignore the fourth state. Let's just do the state. Let's see. So what we're looking at is this A and this B state. This is our acceptance state. And if this actually does end up being B, then it goes here. Surprisingly coherent. surprisingly coherent. That does look kind of right. Ah, that's unsettling. Okay, well, I think I've gotten it right. Okay, sure. Since yeah, okay, I'm just gonna move this a bit down. I think I got it wrong, but still. Okay, so now we're looking at B, right? Now we're looking at B. 0 plus 1. Come on, really? It's fucking zero, and then zero, and then 1 0, and then fucking what? Then 1, accepting. Damn, we cracked it. Crazy work. All right. Okay, that's a joke. Okay, watch out, I get it wrong. Fuck you! Finite automaton may have more than one accepting state. You're taking the piss. Now you mentioned that. Honestly, mate. Honestly, Jesus. Some people, man. Some people. Honestly. What the fuck? Honestly. Oh, now I'm pissed. Oh, whatever. We'll just assume that this only had one acceptance state because they only emitted it in C, so I guess it's only necessary for C. So, we'll draw 0 as we usually do, and it's pretty obvious. If it's 0, that it loops back into itself. If it's 1, then it goes to 2. Wait, that's an or. It's not and. It's or. Okay, so actually, since the initial state can't be the accepting state, you go to here and then 1. Okay, so yeah, since the accepting state cannot be the initial state, we can't have this be that. So let's see, 0, 1, 2. I think that we have 3 states, and that's the minimum we need. If it's 0, then it goes to the 0 loop, and it just loops up back on itself. And if it's 1, then we just do this. Yeah, so that's the simple answer to C. I feel like A was just to get ourselves acquainted with it, and then it got easier. So now let's do some slightly harder, kind of proof based exercises. I think these two are proof based. So given the fact that regular languages are precisely those accepted by finite automata. Given this fact, show that if L is accepted by some finite automaton, that L inverse is also accepted by some finite automata. L inverse or -1, depending on what you want, is consisting of all words of L reversed. Quite interesting. I had to think about this. I actually this was like the okay. Look, okay. Just to kind of preface, I did read all the chapters throughout just to make sure I didn't have like anything horrifically confusing. I didn't look at the problems too much. I was a little curious, so I looked at the problems for the first bunch. So I didn't work out the solutions beforehand. But I did have some idea, and this kind of stuck in my mind, so I thought about it. And after some thinking, I've come to the conclusion that you probably have to use some of the bits from this chapter to solve it. I know that sounds kind of fairly obvious, but fairly obvious things don't come obviously to me. So, language L. So, language L is accepted by some finite automatons. So, it's probably some kind of word. If you've read GEB, Go to Internal Braid, then you probably like know, then you probably like already have the answer, to be honest. You're probably smarter than me because I haven't read it. But essentially you can think of all of the regular expressions as being built from these three rules, right? So so actually we can consider the inverse of it. So if x and y are regular expressions, so is the concatenation xy. Okay, so yeah, we could actually if x and y, oh shit, no, x and y are regex, xy is regex. So therefore, if I actually not therefore, but you could probably infer it. I think. Actually, yeah, that's a great point. Okay, so okay, brain fart. Okay, let me try to explain. Right. So if f and x are regex, then x y is regex. Does not imply if fx the concatenation is regex, then x y or regex. These are not equivalent statements. These are not equivalent statements. As studiers of the TMUA will know, contrapositive is the equivalent and is true. So if the contrapositive is true, then the original statement is true. If the contrapositive is false, then the original statement is false. And yeah. So what a contrapositive is if xy is not regex, then xy is not regex, which less useful to us, I think. Probably, yeah, less helpful. I mean, fundamentally, right? I think the same argument still works. Like, I think this is true. I just don't know how I'd go about formally proving it because I haven't studied proofs very much. This is kind of again another fool thing to admit on the internet. I'll probably trace back, but I haven't done many proofs yet. There's a book I've been wanting to read on proofs, mathematics for computer science. I've wanted to read forever. I just haven't had time yet. But yeah, I'm not great at proofs. I haven't had the like training, so you're gonna have to bear me with me here. I think it's fair that we can just assume this though. Yeah, I think it is fair we can just assume if xy is a regex, then it is that. If and also if xy uh yeah. So if xy or x plus y is regex, then that. So yeah, that's what we're saying is true because we're just guessing. We'll look up the answers later, I guess. If oh, fuck if if fx regex, then if regex all regex can be decomposed into primitive expressions by. Yeah, so all of them can be decomposed since we know what was the wording again? L is accepted by FA. L can be represent and regex. So therefore, so therefore, L can be decomposed into primitives And since it can be decomposed into primitives, again, this is not the correct wording. This is not formal. I'm just writing what I think. Since it can be decomposed, then we can interruptions aside. And I've somehow managed to mess up my OBS, I hope. Not. Okay, there we go. So, since L can be decomposed into primitives, we are quite close to the answer. It's just that. So, yeah, since L and L1 made of same same parts in different order. I don't know if we're going too much into detail. So L plus 1 can also be decomposed actually. Decomposing it doesn't really make a difference, does it? Now that I think about it, because we've kind of proved that O negative 1 can be decomposed, or L inverse can be decomposed into a regex. Um, and then now what? You can recompose it into regex, I guess. And now O negative 1 can be recomposed to regex. Since uh since all I don't know, I got it. Okay, since L must be by use of like those theorems, regex rules must also be created by regex rules. Must be regex. Okay, so therefore it must be regex because since it was created by regex, the regex rules. Since the original was created by the regex rules, the inverse must also be created by the regex rules. Therefore, it must be regex. I hope that works. Again, shithead proofs. We'll get better. If someone can tell me in the comments if it's wrong, if someone bothers to watch this video. So yeah. Question 3. How would you argue no finite automaton can accept all palindromes over a given alphabet? There is now, okay, There is a logical explanation for this that I've heard from a previous video before. Here is as follows, right? Basically, what you're considering is you could properly write something. Now, this may sound obvious, that accepts A, B, C. The A, B, A negative 1. That is not that difficult. At least okay. No. You can't accept that for the general case, but you could accept like 0, 1, 1, 0, 1, 0, 1, or a special. Sorry, is it a special marked palindrome? Okay, fine. So yeah, yeah. So not marked palindrome, so it doesn't matter. We'll just use normal characters, 0, 1. So yeah, 0, 1, 1, 0, 1, 1, 0. Can you make a finite machine that accepts that? Yes, you could theoretically construct some kind of monstrosity like this one that accepts this specifically, right? And then you could make another brute force. Okay, so let's imagine something worse, right? Like 1, 0, 1, 1, 0, 1, 1, 0, 1. And then your question, how would this brute force handle this? Well, it's obvious, right? It's obvious. Frankly, obvious. You would just make something that also handles this, right? You just expand it a little too. But then you make third case, right? You make 0, 1, 0, 1, and so forth, right? So you'd have to essentially keep expanding it infinitely. And there is no way to make some kind of clean state transition diagram like this one that accepts it. Now the reason for that, I guess, would probably have to do with the fact that Z, or okay, we'll write it down, right? So words Z. Oh wait, I'm a dummy. Am I a dummy? Oh no, I'm not a dummy. Okay, no. Yeah, no, I'm not. I'm not a dummy. I think. Yeah. Okay. So ZMC. Yeah. So words of the form ZMZ inverse, right? So it can't be accepted. But how do we prove? Oh Lord, I'm running out of battery. Okay, that's not good. Yeah, I left my charger in my room. I'm not in my room right now. How long have we been going? I guess I should probably sleep soon. See here, an hour. It's all right. Could be worse. Could be better. Hmm. I have like an hour before I sleep. I can probably at least get through chapter 3. Let's go grab our charger and also some water. Okay, let's go on break, I guess. Ooh, ooh, go on break. Go on break now. Why aren't my keyboard shortcuts working? Go on break. Fucker. Go on break. Oh, there you go. Hey, it worked. Wait, so this does not work otherwise. Oh, it does work. Oh, it does work. Okay, never mind then. I guess I have to mute too. Ni hao. Whoa, whoa, Lila. How do you change this? Doo-doo. Boop. Yep. Okay, so we are charging and we are up. Right, so observations. I accidentally drank from a cup that's been there like 3 days. Hopefully, I mean, it didn't have anything green in it like last time, so it should be fine. I love being eco-friendly. Algae are probably a good source of protein, right? Algae protein. Yeah, see, high protein concentrations. I'm bulking. Amino acids. Acid, yeah, I love acid. I love ammo, good things, good things. See, I'm being so eco-friendly. Rapid growth. I love rapid growth, I think. I just forgot this is the wrong tab. Okay, I'm just to show you I'm not delusional. No, I am delusional. It's okay. Okay, so yeah, sustainable, plant-based, high protein, can be amino acids, rapid growth. See, I wasn't joking, I'm not schizophrenic. Yay! Yeah, so let's continue. Oh Lord, what's happening to my screen? Oh Lord, light mode. Okay. Turn down the lighting a bit. Jeez. Okay, so we are looking at words of form ZMZ inverse. I didn't think about this. I was busy getting myself some water. Lovely, lovely, lovely. But we continue. How would you argue no finite automaton can accept all palindromes? Hmm. Difficult. Difficult. How would you argue it is the question. Like I think it's intuitive to see you can't do it, but how would you argue it? How would you logically prove it? Right? There are multiple accepting states possible, so we already know that. Oh wait, no, I've got a simple argument. There are an infinite number of possibilities for Z. Shit, come on, you can do it. What are you doing? Come on. What's my pen do? Come on. Oh my days. That's what happens when you get off brand. Ah, damn it. Only I hadn't lost the original. Okay, right. I've taken the pen's battery out. Let's just give it a. Oh, I just. Okay, so now that we've moistened up the battery a bit, you know, uh, it's hopefully not made it explosive. Yeah, it works. Just wanted me to blow on it, I guess. No, I mean, if it helps, if it's to the pen's taste, so then I'll do anything. There are an infinite number of policies. Blah, 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 for Z. Be what the hell? Be reflected in Z. Since there are a finite, oh no, number states. On. Lord, what are you doing? Have you actually run out of battery? On stream, you're mocking me. It's not like these things have a bloody gauge or anything to tell. It's outrageous. Swapped out the battery like 2 months before. I mean, I do have like 80 million of them sitting around, but still. Is it time for another break? I think it may be time for another break. Okay, let's try one more time, right? Nice and erotic. Okay, so without further ado, nope, it's out. All right, we're cooked. So, actually, wait, did I just pop the other way around? I wasn't looking at whether it was positive. Nope, it's definitely the wrong way around. Okay, time for break number two, boys. Or girls, gender inclusive, or non-binaries. You never know. Or fourth. Okay. Wait, no, this is the break button. Yeah. So bye bye. Off to get a battery. Yes, we found a battery. Yay! Turns out what we do not have in what we don't have in just like I know I did have them in stock, but we did not have we didn't have them readily available. That's the word. We didn't have them readily available. We did not have quadruple A batteries, not triple A. Right. New factoid. Those exist. So, hopefully I'm back on screen. How to do this? Ooh, I'm trying to remember mindset. Oh yeah, this. Okay, so hopefully I'm back on screen. We are doing a systematic. No, fuck what? Finite amount of states. Okay, so back to the palindromes. We've got to. Oh my days! Please work. We have to solve this quickly now. Since there are a finite number of. What are you doing? What are you doing? Huh? Yeah, you've gone funky, haven't you? Yeah, I've definitely gone funky. Okay, give us a second. Oh, an entire thing's gone funky. Okay. Good lord. This is what happens when you leave your computer alone for a while. All right, give it a second. Okay, what about now? Ah, it does work. Okay, wonderful. So back on track. Since there are a finite number of states. Oh, the pen stopped working now. Very interesting. Ah, but didn't help. Didn't drop it. I have laser reflexes, agility, dexterity. Okay, yeah, that did not help. So I have to accept the possibility my pen might just be broken. Possibility. So you're gonna pretend it's not good for a while. Is that a thing inside my pens? Let's hope that's not, dust inside, and let's just hope that's what's supposed to be inside a pen, which is a battery. No, not a battery, since it took it like electricity bits. Ah, wondrous, wondrous. Yeah, good. Okay, finally. Okay, since there are an infinite number of states, a finite number of states in an FA, not. Oh my lord! It's touchscreen working. What in the hell? Oh, so light taps aren't working, which I think is a problem I've seen before. Yeah, I'm light tapping all over the screen right now, but you're not seeing it. Right, so we are gonna have to either tech support this right now, or you know what? Sure, let's tech support this right now. Why not? Let's new stream content. We're tech supporting. We are supporting our tech. Ignore me trying to pirate that. Light taps on window on touch screen. Should I include the motto? I guess Omnibus. Not working. Okay, I guess we'll leave out the fact it's Tommy Bookaxe. Oh, I just reviewed a Tommy Bookaxe to the internet. Oh, whatever. It's not secret. Yes, I am using an Omni Bookaxe. I don't have a PC. I don't think PCs are necessary for what I've done so far, which is not much. I am a computer scientist, yes. I just don't have a PC. I have done this before. Like this is a recurring issue, so um control panel. That's actually a fantastic idea. Only for one that we can do off stream. Okay, so that was it. Okay, wow. Wonderful stream. I guess that pretty much concludes chapter one, chapter two, sorry, I guess, or chapter one for you, I don't know. Which is that since there are a finite number of states in an finite automata, it's impossible for one single finite it's impossible for any finite automata to take on all of the infinite possibilities, which is why you can't do it. So yeah, pretty obvious. I will say, this has been fun. I honestly I haven't been that productive. I said it was. Did I say that on stream? Did I say that on stream? Was I just no? I don't think I was. Okay, so I'll be fully honest with you, right? And I know the U.S. unis are gonna look poorly on this, but these past few weeks have not been the most everything. And I started streaming in May, right? May was quite a long time ago. It was before the World Cup, so may as well have been a lifetime. Hmm. It's hard to explain to someone who okay, let's be honest. It's hard to explain to normal people. Uh, it's been like a month, and during that time, I've done a little bit of everything, but I haven't done as much of everything as I hoped, right? Might have been better if I stuck to one thing, but that's not how I work, unfortunately. So it's been scattered, and it's just not been what I've been looking for in terms of the summer, especially the summer before my applications, right? Those are particularly important. So, it's not the perfect story that the US universities are looking for. They're probably looking for me to have started two nonprofits, Safe an Orphanage, cured cancer, and just been more of a person than I have, but I've not, and yeah, you know, I do kind of regret it. It's just, it's not much I can actually do about it now except pick my ass off the ground and start working. So, yeah, we are now working. I guess. Well, I guess no, we're not working anymore. My pen is broken. My touchscreen is broken. Many things are broken, but this stream has been a lovely start. I've only managed to do one chapter. In the future, we'll see if we can do a bit more, obviously. And about my future plans, obviously the new Turing Omnibus, I'm trying to finish it before the end of summer. I'm also trying to do the Step Foundation module. So that was one of the streams I set up a while ago before I decided not to do it. By decided, I mean I just couldn't get my ass off the ground. Yeah, and then more TMUA content is coming. Hopefully some structure and interpretation of computer programs, which is a book that I've been reading and I've found it lovely. I've made some notes on it, not on stream, just kind of as like a practice for when I do get back on stream, which I have done now. So hopefully I'll be doing some content on that as well. But if all goes somewhat smoothly, which I hope it does, I should be seeing you tomorrow. So yeah, let's hope I get this whole thing fixed before then. Yeah, see ya. Maybe I should have like a catchphrase or something like that's copyrighted. Yes, laser eye, yeah.